Hello, I'm Owen Davis, and today we're going to be looking at energy stores and transfers. Today's aims are to understand the definitions of a system and how the energy is stored within this system. Then we look to understand the transfer of energy in a physical system. Now, I've said the word system a lot already, so what is a system? A system is defined as an object or group of objects that can be measured. So we can measure a car's speed, our speed, a cup of water's temperature. This is what we mean by systems. It's something that we can measure and observe. Yeah. So we have energies and we describe them through different stores. So it's your turn. Write down all the energy stores that you know. Okay, nice. Well done, guys. I'm going to go through all the energy stores and you'll recognize some, and you did say some, so we'll get going. We have nuclear energy. This is the energy contained within the nucleus of an atom. We know when we split an atom, there's a great release of energy. This is what powers our nuclear power stations. We have magnetic energy, and this is the energy due to the force of attraction or repulsion of a magnet. If you've ever tried to put two north ends of a magnet together, you feel a repulsion. That's that magnetic energy working. We have gravitational potential. Now the potentials are quite tricky. The potential is the energy of an object when it is raised off the ground. So let's picture an apple, right? It's sitting at the top of a tree and it's not falling yet, and it's sitting there with a bunch of gravitational potential. Now we'll quickly look at kinetic energy, and this is the energy of an object because it's moving. So if an object is moving, it has a kinetic energy. So our apple is at the tree. It has this gravitational potential in it. It then falls and starts to fall. This gravitational potential converts into kinetic energy as it begins to move. So next time you're looking at a tree, you can say that apple's got potential. So we then look at thermal energy. This is the energy within a system due to its temperature. So we have a thermal energy. The bottle of water on your desk has a thermal energy. An ice cube has thermal energy. But the ice cube will have much less thermal energy than something much hotter. So even a human being has greater thermal energy than something that's colder. Okay. Next we have electrostatic energy. And this is the energy, again, due to an attraction or repulsion, but this time of two charges. So we're looking at point charges here instead of our magnetic charge. Can anyone tell me whether there will be a repulsion or an attraction for a positive and a negative charge? Nicely done. Yep. So just a little reminder. Opposite charges attract. So positive and negative are attracted to one another. Like charges repel. So positive and positive, negative and negative, there will be a repulsion. And this attraction and repulsion is our electrostatic energy. Next we have elastic potential, very similar to our gravitational potential here. But when we stretch an elastic band or a string, you feel that tension in the band. You let go and it pings away, it moves off with kinetic energy. So elastic potential is the energy stored within a stretched string or an elastic band. Finally, we have chemical energy. And this is energy transferred during a chemical reaction. So we look at a battery, for example. When we plug it into a controller or a TV remote, we have a chemical reaction within that battery supplying energy. So here's just a table of all the different energy stores and a description for your revision. Next, we're going to look at energy transfer, and we need to look at something incredibly important, and that's the conservation of energy. So the total energy of a system is constant. Energy cannot be created or destroyed. It can only be transferred from one store to another. Okay? So here we have 4 different energy transfers. We have mechanical. This is a movement transfer when there's a collision of 2 cars or you're applying force to a shopping trolley, for example. That's a mechanical energy transfer. Electrical, This is from one of our power sources. So again, we're looking at a battery or a cell within a circuit. This is an electrical energy transfer that's providing power to components within the circuit. We then have heating, and this is a thermal energy transfer. So this can be done by conduction, convection, or radiation. So if you're sitting near a radiator, for example, this is a heating transfer as it heats the room up. We then have radiation, and this is an energy transfer through light or sound. Okay, so we're going to look at transfer diagrams, and these are a great way of representing our energy transfers. So we start off with our energy store, then we look at the energy transfer that occurs, and finally the output energy from this transfer. So let's have a look at a scenario first and see if we can get to grips with it. So we have a child going down a slide. I've given you the initial energy store here. So the child's at the top of the slide, so it's got a gravitational potential, okay? Can anyone tell me what the energy transfer and the output energy will be? Exactly, there's movement, so we're looking at mechanical work. Now, it's kinetic energy because the child's moving, but we also have thermal energy from the friction of the clothes and the slide. So if you feel the slide afterwards, it's going to be a bit warm. Again, this is this conservation of energy. We cannot destroy energy, it's just being transferred elsewhere. Okay, now we have boiling water in a kettle. So we have electrical energy from the kettle. Can anyone tell me the transfer energy and the energy output? Yep, so we have electrical work done with the heating element, and then we have thermal energy of the water and thermal energy of our surroundings, again looking at this conservation. Well done guys, that was energy stores and energy transfers, and we will have a look at work done equations next week.